Once again, you are welcome to this class for MTA 303, Vector and Tensor Analysis. So can you see my screen now?
Yes, sir.
Yes, sir. Yes.
So on that particular topic, I can see it's a kind of summary they gave you guys, but in this case, we'll go a bit detail. Let's see how we can go. When we'll be talking about vector, differentiation. That's why I advise you guys to try to, do a kind of revision in your calculus. It will help you. So let's move on. We said let's R of U be a vector depending on a single scalar. Please mute yourself. Variable U. Then we have the change. You remember delta R with the change of R over change of U, which is equals to, the definition is RU of U plus change in U minus RU of U. Everything divided by change in U. Where your U is denoted, where delta U is the same thing as increments in U, where U is equal to increments in U. So I'll try and list different validations. Okay, let's look at the R, the U. Is the same thing as the limit of change in U tends to 0, where we have delta of R over delta of U, which is the same thing as the limit, we know it is up, delta U tends to 0, meaning R of U plus delta U minus R of U, all divided by delta U. If the limit exists, if the limit exists, this condition will hold. Otherwise, it's another thing entirely. But in this case, we'll be talking about space curve, where we're talking about different coordinates, and all I would just need to do is just to be specific, and I don't want to bore you with the story, but I will say this. Note, on the space curve, when you have let's say we have, I'll just give us the definition at any point, that when you have R of U equals to S of U I plus y of u, j, and plus z of u, k. Under the particular coordinates, at any point of x, y, z, then we have all this definition that I just gave us. That now leads us to the definitions we are actually talking about. That the specification of the vector function r of u is defined as x, y, z as a function of u. If a certain thing exists, that is, if the limit change of u tends to 0, that is, change of r over change of u equals to the r du. The r du exists. If it is exists, now we're going to have the r du to be the s du I plus the y du j plus the z du k. Now, we are trying to establish this following definition based on what we have on hand. But now let's look at the differentiation formula itself. And we will also try to prove one or two. Then I will ask you to go and prove the rest by yourself. That is the differentiation. If you check your past question, you will see some of those theorem formula, the way they prove them, or the way they ask you to prove them. So if A, B, if A, B, and C are differentiable, vector, function, function of a scalar u, and phi is a differentiable scalar function of u. Then we have the following. Number one, our du in brackets a plus b is the same thing as the a over du plus the b over du. So number two, when you have du of a dot b, it's the same thing as a dot db over du plus the a over du dot b. Are we there? Number
Yes,
three.
sir.
Yes, sir.
When we have du of a, this is cross, this is not multiplication, b is the same thing as a cross db over du plus the a over du plus B. So the next thing is when you now have number 4, you have d du of phi A. So it's the same thing as phi dA du plus. So what's this particular number 4 and number 4 and number 2 is saying? They are using the product rule. You know,
Yes,
in the
sir.
product rule, you hold one constant, you differentiate one. You hold another one constant, you differentiate it. So that is the product rule. Du dA. So then we have the fifth one, which is also similar and interesting, is d du of A dot B plus C is the same thing as A dot B plus dC du plus A dot dB du plus C, then plus the A du dot B plus C. So we have to be careful when you are asked to solve some of those problems. So we have d du here. I can open this one, A plus B plus C is equals to A plus B plus dC du plus A cross dB du plus C. Then plus the A du plus B plus C. So all these things will be looking at them one after the other. This is ordinary derivative of vector, but you can also look at the partial derivative also. If you are given in the partial, how do you identify for the one of partial derivative? Let's move on to partial. Then we check the higher order. For partial, I will not give you too much notes. If you want notes, please, you can check your course material or on the internet if you want to know more about it. But let me just quickly go to so that we can move to the example and see how it's been applied. So if A is a vector depending on more than one scalar variable, remember the first one is scalar variable, is a single scalar. But when you have a vector of A depending on more than one scalar variable, we say x, y, z. So for example, when you have A, you have A into A of x, y, z. So meaning that I'm going to use partial derivative to differentiate this. Remember, I'm dealing with how many now? I'm dealing with 3. So now for this one, now for us to write this one in partial derivative, we all know the sign partial derivative of the x. Now I want to differentiate x alone. It's going to be the limit of change of x tends to 0, meaning A of s plus change in x, y, z, minus A in bracket S, comma, Y, comma, Z, all divided by change in X. If, don't forget, these limits exist, and similarly, you can also check for Y. If you want to check for Y, it's going to be D that A that Y equals to the limit of change in Y, don't forget, tends to 0, is going to be A of X, comma, because it's Y we are dealing with. So you have extension to Y, which is our increment of Y. It's going to be Y plus change in Y, comma, Z, minus A in bracket S, comma, Y, comma, Z, all divided by change in Y. Any question on that? Any question, please?
No question, sir.
So we do the same thing for Z.
Sir,
Yes.
and that theorem 2, where we have a DDU A dot B equal to A dot DB DU plus DA DU dot B. Can we have B before that DA DU?
Now, this is the logic behind it is this. Let me quickly explain. I'll use another pen. Now, look at this one. Is that not what you're saying?
Yes, sir.
Now, what we are doing here is hold A constant, differentiate B. There is no one you can have the B dt, any one you can put it in front, put it. Is still multiplication. Order does not matter. Are you getting it? You can choose to first of all differentiate B. You can choose to first of all differentiate A and hold B constant. 2 plus 3 and 3 plus 2 is what?
5, sir.
Are you getting the point?
Yes, sir.
So, have I answered you?
Yes, sir.
Okay. So for the last one, we have the Z. So we have the Z. It's the same thing as limit of change in Z tends to 0. A of S, comma, Y, comma, Z plus change in Z minus A, S, Y, Z. Divided by change in Z. So they can ask us to differentiate the higher order. In case you are to differentiate higher order, let's look at higher order, higher derivative. Higher derivatives can also be, let's say, the square A, the S squared is the same thing as d dx of the A ds. Same thing goes to B to Y, say d square A, the Y squared can also be d dy of the A, the Y. Same thing goes to Z, the square A, dz squared is equals to d dz. Are we together now?
Yes, sir.
The A dz. So it moved on in that way. But what about when I have this type of equation? When I have the square A, the x, the y. How do I do it? How do I go about it? Just order does not matter, like I told you. What you need to do is just to be careful. Look at this now. The x in brackets, the A, the y. So the same thing happened here. That's okay, d, the square A, the s. So you do the same thing to it. So d, the y, the A, the x. So the same thing, if you have 3, if you have 4, if you have 5, you just make sure you take it one after the other. You just take it one after the other. So before you know it, you finish the differentiation like that. So now let's look at the rules that governs this partial derivative. Differentiation of vectors. So you can say number 1, d the x of A dot B. The same thing we did up, A dot the B, the x, plus the A dot the B. So number 2, we have d the x of A cross B. It's the same thing as A plus dp dx plus the A dx cross B. So now that we have this, we move on to, okay, let me give us this particular one before we now look at some of the examples in this way. Then let's look at this number 3. This number 3 says d square the y the s as A dot B, the same thing as d dy in bracket d dx of A dot B equals to d dy of A dot dB dx plus the A dx dot B. So you can now differentiate it again. Remember, you are still in this one. So it will now turn to A dot d square B dy dx plus the A dy dot dB dx plus the A dx dot dB dy plus the square A over dy dx dot B. etc. So you can continue from there. So now let's look at this. If A is equals to A1I plus A2J plus A3K. Then the A will be the A1I plus the A2J plus the A3K. So like that, you can begin to define it this way, but that's not our target. But let's look at the example one. Let's quickly move to the example one. Given, example one says, example, it said, given R equals to sine Ti plus cos Tj plus T this. The question says find A, the R over the T, B, the square R over the T squared, C, the R over the T, then D, magnitude of 2R the T squared. So we are asked to find this. So how do we go about this? According to the definition we have here, this particular definition that I gave you initially, that said the R over the U. Now we have the R over the T now to battle with. So for us to solve this one, all we need to do is just to substitute the same thing. Solution. Let's look at the solution. Under the solution, you have the R over the T to be equals to D dt, open the brackets, you put the I here, sine T I plus D dt on the brackets, cos T. You do them, you put them coordinate by coordinate, one after the other, plus dt of T. Okay. So anytime when you differentiate sine T, what do you have?
We have cos T.
You have cos T. Thank you. Cos T I. Then when you differentiate cos T, what do you have?
We have minus
sine T.
Minus sine T. Yes. G. Then when you differentiate T, what do you have?
We have 1.
You have 1, which is 1 multiplied by K is equals to K.
Yes.
So we literally differentiate, we solve A now. Then B. The B says D square R over the T square. Please mute yourself. It's the same thing as D dt of the R over the T. Which is the same thing as D dt. We know the R dt already. We have to differentiate it again. So put it there, cos Ti minus D dt into sine t j plus d dt of 1k. So which is going to be cos t high is equals, when you differentiate cos t, what do you have?
Minus
sine t.
Minus sine t, thank you. I. Then when you differentiate sine t, what do you have?
we have cos t.
But when I differentiate one, what do I have?
I have 0. It's 0.
So that settles the matter. Then I proceed to C. So this is the solution for B. Then for B, I have the absolute value of the R dt. From the previous class, we have for us to define this, it simply makes the square root of s squared plus y squared plus what?
Z squared.
Z squared. So which is the same thing as what is representing our x in this case?
Minus sine t.
No.
Sorry.
The
Our
R
x?
dt.
The R dt, sorry.
Is up. What is your R dt? Check your notes. Are you there now? Hello? So what is y squared?
Sine squared t.
No, negative sine. Negative what? Sine t. Negative sine t. Plus 1 squared. So you agree with me if I put it this way? Square root of this is cos squared t, right?
Yes, sir.
Cos squared t plus sine squared t plus 1. Cos squared t sine squared t is equal to what?
1.
Recall that cos squared t plus sine squared t is equal to 1. Therefore, we have square root of 1 plus 1, which is equal to square root of 2. Please take note of that. Don't say the question is wrong when they give you something similar. It's not wrong. It is you that you need to open your eyes very well, please. So we can go ahead by saying square root of. Now we have to do the same thing to the square r over the t squared. So the square r is what?
Minus sine t.
Minus sine square. Minus sine t squared.
Sine square t squared.
Plus minus cos t squared. Everything equals to what? 1. Do you agree with me?
Yes, sir.
Any question before we move on? Okay, let's look at another example. Example 2 now. A particle moves along a curve. Whose parametric equation are s is equals to exponential minus t, y is equals to 2 cos 3t, and z is equals to 2 sine 3t. Where t is the time. Where t is the time. A. Determine its velocity and acceleration at any time. At any time. B. Find the magnitude of the velocity and acceleration at t equals to 0. So for us to solve this one now, we need to get the position of r of a particle, or of the particle. Now, the position of r of a particle is, let's look at the solution. The position vector r of the particle is r equals to x I plus yj plus zk. So, which means, what is my x? Anybody?
Exponential
minus t.
Exponential minus t I. What is y?
2 cos 3t.
2 cos 3t j. And my z is
2 sine 3t.
2 sine 3t. Okay. Then the question says we calculate the velocity. We know the velocity is what? The r. Then don't forget r is here. Velocity is, our v is equal to dr over dt. Our v is equal to the r over the t. Who can tell us why we have the r over the t?
I think we are differentiating the position with respect to t.
Okay, thank you. Let's continue. So we have it to be d over dt into exponential minus t I plus d over dt into 2 cos 3t plus d over dt into 2 sine 3t. Okay. So for us to differentiate this, so we're going to have, if you differentiate exponential, what do you get?
Minus exponential
Minus exponential minus t I. Sorry, let me ask this question. Who is not clear to, who is the, if you don't know how we got minus exponential, please raise up your hand so that we can take care of that before we move forward. Anybody in that class?
I sir.
Okay. Now let's just quickly digress. When you have, because you can't cram this one. Let's say, I'll clean it again. Let's say y equals to exponential 2t. They now said dy dt. It simply means you have to differentiate the law that governs exponential is so powerful to the point that you only differentiate what is up, and when you are differentiating what is up, you still keep what is there. You just keep it there. Okay, let's do it this way. Let's say, let me use 2t, yes, 2t again. If I'm differentiating 2t now, what do I get? It simply means dy dt is the same thing as d dt of the entire bracket and write exponential back. So I will not differentiate this now. If I want to differentiate d dt of 2 now, what do I have? When you differentiate 2t, what do you have? Hello? You have 2. And replace what is there back. Can you get the explanation now?
Okay.
So if I have y over equals to exponential negative 3t, I'm going to have dy dt will now be d dt of the entire power. Rewrite what is there.
Minus 3t.
So now, when I'm differentiating, what do I have? Minus 3.
Minus 3.
Exponential minus 3t.
Minus 3t.
Are you getting it? But
Yes, sir.
in a situation whereby I have y equals to exponential minus t squared, what do I have? I will have dy dt equals to d dt of minus t squared, right? Exponential minus t squared. So what do I have here? Minus what?
2t.
Minus 2 should be minus because 2 will come down.
Are you getting it now?
Yes, sir.
Now, let's go back to our question. If you want to differentiate y, exponential minus t, so I will have what? D dt of negative t. Are you getting it? Exponential minus t. So what do I have? I will have minus 1 exponential minus t, which is the same thing as minus.
Thank you very much, sir.
So that's the way we come across it.
Thank you, sir.
So we can proceed now. So I can clean the board. So that we can continue what we are doing before. So it happens to all the exponentials, at times all the linears and some other things. For those of us that are doing elementary differential equation, you will see a lot of it in it. Or for those of us that have done it before, please check your notes, go back to it, revise it. It will help you. Is that okay now? Okay, let's move on. So in this case now, you agree with me that exponential, we can now use this to differentiate the exponential the way we do it the other time. So here we have, let me use our pen. Now differentiate this, we have minus exponential minus t I. So if you want to differentiate this now, the same thing happened to all these our cos. When you are differentiating this, when you're differentiating 3 cos, when you are differentiating 3 cos t, it will be what? Negative 2 times 3, 6 sine 3t j. The same thing happened here. When differentiating sine with 3, 2 will multiply the 3 again, will be 6 cos 3t, and you remain the same thing there. So finally, we have exponential, negative exponential t I minus 6 sine 3t j plus 6 cos 3t k. So that is the R dt. So the question says, that is for velocity. So for the acceleration, remember, is the square of that. Acceleration means A, the A is the same thing as you differentiate your velocity again for acceleration. Is A equals to d squared R, the t squared, equals, now, if I'm differentiating these second times, I'm going to have d dt of minus exponential minus t I minus d dt of 6 sine 3t g plus d dt 6 cos 3t k. So you do the same thing the way we did the other time. Remember that when you differentiate now, the negative will nullify the negative. Do you agree with me?
Yes, sir.
Kausara,
Yes, sir.
do you believe that when you differentiate this, what do you have?
We
It
have
will be
positive.
You have what?
It will now be exponential.
Thank
It's
you.
exponential minus minus t.
Minus t only. Thank you. So minus. Now, when you now differentiate this one, you have 3 times 6, 18
cos
3t j. Then when you differentiate cos, you have negative sign
minus 18 sine 3t.
We plus 18 sine 3t.
Yes, 3tk. So you can mute yourself. Thank you. So we proceed. The B aspect of the question says what? The B says at 0, what is the magnitude of velocity? And at 0, what is the magnitude of acceleration? So we start from there. At t equals to 0, what is the R dt? We have the R dt. Let's go to the RDT is here. When you substitute 0 here, what do you have? Exponential 0 is what?
We have 1 plus 6.
No. Exponential 0 is 1. 1 multiplied by negative. You have negative I. You remember? You know that is minus I. Okay, let me explain. It's negative 1, right? I. Let's continue. Then when you substitute 0 to where you have sine 3, 6 minus sine 3, when you put 0 here, sine 0 is what?
Sine 0 is
0.
0. 0 multiplied by 6, everything here is 0. So you have nothing to do here. Then when you now say cos 0 is what?
1.
Cos 0 is 1. 1 multiplied by 6.
6.
So plus 6. Okay. So then when you now have the square R, the T squared, we have, now this is the square R, the T squared, which is this one. Don't forget your A is equal to the R squared, the square R, the T squared. So if you substitute 0 here, what do you have? You have 1. No, this is finally says minus I plus 6K. So here we have what? 1 I, or 1 into what? I minus 18J. So this entire side, this particular side returns to 0. Since side 0 is 0. So finally, you have I minus 18K. 18J rather, sorry. $18J. So we can now go ahead by looking at the magnitude. Then the magnitude of velocity at t equals to 0 is what? Let's go to the magnitude of velocity. This is what you have at t equals to 0, right? So it simply means I have square root of negative 1 squared plus 16 squared equals to square root of 37. Excuse me.
It's 6 square, not 16 square.
Thank you, 6 squared. So then let's look at the magnitude of acceleration at t equals to 0 is square root of 1 squared plus negative 18 squared, which is equals to square root of 325. Any question, please? Any question? Then another question can also come in the, I've seen this question before. Some of you also can also check your past question. They are there. They ask you to prove. Let's look at this. Oh, is another example. Let me put it this. Number 4, right? Or number 3? Number 3. So if A, that's a final answer, you can find the square root of this and get it. If A and B are differentiable, function of a scalar U, prove the following. A. How many of you have seen this type of question before? Du A dot B equals A dot dB du plus the A over du dot B. Then B, they can ask you, said, d du of A cross B is the same thing as A cross the B of the U plus the A over the U cross B. So how do we solve this problem? They are very simple thing. Let's solve it. Solution for A. Let A equals to A1I plus A2J plus A3K. And let my B equals to B1I plus B2J plus B3K. Then d du here is A dot B is equals to d du in brackets A1. That is, you remember the dots, the way we do, when you have I dot I is equals to 1. You remember? Hello?
Yes, sir.
So that is why you can see we cannot look at that opportunity by saying 1, B, I to I, J to J, K to K, plus A2, B2, plus A3, B3. For those of us that have missed the class, please go and watch the video so that you can also flow with what we are doing. So we have it here to be. We can now open the brackets by saying A1, the B1, the U, plus A2, the B2, the U, plus A3, the B3, the U, plus you pick the one of other one too, the A1, the B, the U, B1, B1, yes, plus the A2, the U, B2, plus the A3, the U, B3. So at the end of the day, we can have A, remember A1, A2, A3, they are equals to A. B1, B2, B3, they are the B1, the B1, the B2, the B3, they are equals to the B. So we can now say dB over du plus the A1, which is the A, du dot B. So that is the proof they asked you to do. Any question? Any question? Silence means no question.
Yes, sir.
Okay. I'm happy at least you don't have question. It simply means that you are there perfectly. You understand it perfectly. So let's look at another. We've not finished it. B aspect of it. It says du of A cross B. You remember the way you solve the cross using the matrix form. You just use a determinant theorem of the matrix that we normally use. It simply means d du into I, j, and k, meaning A1, B1, A2, B2, A3, B3. So in this case now, we can, using determinants like I told you, using a theorem on differentiation, of a determinant this become, so let's put it there. We can now say that A1, we have the B1, du, J, A2, the B2, du, okay, A3, the B3, du, plus I, which is the A1, du, the A2, du, the A3, du. So which is B1, B2, and B3. So at the end of the day, when you work it out, you're going to realize A cross the B over the U plus the A over the U cross B. So that is one of the things they ask you to solve. So let me give you this point as an assignment for you to solve. Find the unit find the unit tangent vector to any point on the curve x equals to t squared plus 1, y is equals to 4t minus 3. Z is equals to 2t squared minus 6t. That is A. B, this is A. B aspect of it says determine the units tangent at the point where t is equals to 2. Where t is equals to 2. So don't let me bug you more on that. I want you to go and also check some of the questions in your book and lay your hands on them. So in the next class, we'll talk about more questions on this nature. Then we'll move ahead to be able to solve some of the problem also in the partial derivative and see some other application, probably in geometry. And from then we'll be able to move on to, I will look at the example in mechanics too, so that all these things, you just pick one before we move to chapter 3 of the whole thing. So, any question? Can I stop sharing? Any question? I hope you are able to gain one or two things today.
Yes, sir.
Yes, sir.
Thank you.